We now have two equations that really tell us about the variables that affect gravity. If we're talking about the force of gravity or the weight, we need to know the masses of two objects, one of which is often the planet the object's on, and we need to know their distance apart, which is often the radius of the planet. If we're talking about the gravitational field, which is kind of like the strength of gravity on a certain planet, it's also the acceleration of gravity, then we just need to know the mass of the planet and the radius of the planet. And again, at the end of the day, these depend on mass, and very specifically the mass of the planet, and they depend on distance apart or radius of planet. So in order to investigate that further, we like to throw some questions at you that at first seem impossible to do. For example, this equation has 5 terms in it, so to solve for anything, you need at least 4 of them. But we just kind of throw one at you. And then we talk about how a change happens. And as you go through these problems, figuring out whether the radius changed or the mass changed and how much it changed by, that really gives you kind of some insight into how the equation works. Let's start with the simpler of the two, the effective changing mass, say the mass of the planet. The force of gravity and the gravitational field are directly proportional to the planet's mass, which is one of these two, or it's that one. So since we're directly proportional, force or field changes by the same factor that mass changes by. So if you end up with 3 times as mass of a planet, 5 times as mass of a planet, 1/5 as mass of a planet, you just multiply by the same factor, and that's how you solve it. Because these depend on the inverse square of radius, that's often a little more challenging to do. So I have students just typically write, when they're dealing with radius changes, I have them write the words inverse and square. So when we're talking about inverse, if the radius gets bigger, that means the force or the acceleration gets smaller. As far as the square goes, if the change is by a factor of 2, that means the force, or G, is a factor of 2 squared, or 4. If the radius changed by a factor of 3, the force or the acceleration would change by 9. You see where we're going. So by doing inverse, we see whether the factor gets bigger or smaller. By doing square, we see by how much it happens. Let's do some examples so we feel a little more comfortable with this. So in number 1, it's telling us that the radius is changing. So that's going to be one of these inverse square problems. So we'll go ahead and we'll write inverse. The radius is getting bigger. That means the force is going to be smaller. Square. The radius is changing by a factor of 4. So that means the force must be changing by a factor of 4 squared, or 16. So with these two ideas, the force is getting 16 times smaller. So we divide by 16. So pretty significant change if we went to a planet whose mass was spread out on a much bigger sphere with 4 times the radius. We'd be 4 times the distance from the center, and that would drop our force by a factor of 16. Let's go the opposite way. Let's look at an object that's moved to a planet that has a smaller radius without changing the mass. We're going to solve for the acceleration of gravity rather than the force, but the process is the same. It's still inverse square. So we have inverse. and we have the radius going down. So that means the acceleration of gravity must be going up. Square. This is changing by a factor of 3. So that means the gravity, acceleration of gravity is going to change by a factor of 9. If you combine these two ideas, G is 9 times bigger. So G new will be 9 times G old. That's a very large acceleration of gravity, but this is a planet where its mass is packed much tighter inward, so that we have this extreme effect. The last question is the easiest one. In this case, it says we're changing the mass. So in that case, it's directly proportional. So if mass is 3x, so is force. So the new will just be 3 times the old. So I hope you know how to answer these questions. It just takes a little bit of practice. The mass ones are actually the easiest, but students spend so much time studying these ones that they forget it really is just that simple with mass. So at the end of the day, just make sure you know the effect of changing mass is directly proportional, and the effect of changing radius is inverse square.